Hello grade 8 children. Today I am here to teach you another interesting topic, that's square root in your textbook. That's chapter 8. Before we find out square root, we'll see square of a number. So what is a square of a number? Is the value when multiplying a number by itself. If you take 7 multiplied by 7, we can write 7 square. You can write as power 2. A into A squared. Or if this is 11 times 11, you can write 11 squared. Or x into x, you can write x squared. So this is called square of a number. Now look at this one. So this is a square, one length and one length. One marble is there. 1 times 1. You get 1 squared. 1 squared is 1. Look at this one. This square, 2 length here, width also 2. That's a square. 2 times 2, you get 2 squared. That's 4. So what about this one? 3 into 3. 3 times 3, that's 3 squared, 9. 4 into 4. So row wise 4 marbles are there. Column wise also 4 marbles are there. Then 4 times 4, that's 4 squared, 16. So square of a number is called the perfect square number. The number of columns in the above figure is equal to the number of rows. So these are called perfect square numbers. Here number of columns into number of rows. So that's same as square number. So perfect square numbers, we can say these are square numbers. So what are the square numbers? 1, 4, 9, 16, like that. Fill in the blanks. You have given the number square of a number, 1 squared. What it means? 1 times 1. What's the answer? 1. Number in the units place. So this is units place. That's 1. 2. When you square it, 2 squared means 2 times 2. Then what's the answer? 4. Number in the units place is 4. What about this one? 3 squared means 3 into 3. That's 9. Number in the unit place is 9. 4 squared, 4 times 4, that's 16. What's the number in the units place? 6. This one, 5 squared, 5 times 5, that's 25. So the units place number is 5. 6 squared, 6 times 6, that means 36. Units place is 6. 7 squared means 7 times 7, that's 49. Units place number is 9. 8 squared, 8 times 8, that's 64. Units place is 4. Now we'll find out more numbers. 9. 9 squared is 9 times 9, that's 81. So what's the units place number? 1. 10 squared means 10 times 10. That's 100. Units place is 0. 11 squared is 11 times 11. What's 11 times 11? 121. Units place is 1. 12 squared. 12 times 12. You get 144. Units place is 4. 13. 13 squared. 13 times 13, 169. You can check those values. then the units place is 9. 14. What's 14 times 14? 256. We'll check it. 14 times 14. Multiply by 10 and multiply by 4. 16. 5. So 196. 196 is that. So what's the value here? 6. 15 times 15, 225. Units place is 5. 16. 16 times 16. We'll check it. 16 times 16. Multiply by 10 and 6. 6 times 6, 36. 6 times 1, 6 plus 3, 9. 256. So units place is 6. 17 times 17. So 170. 7 times 7, 49. 7 times 1, 7 plus 4, 11. So 982. 289. So units place is 9. 18 times 18. So we'll check. Multiply by 10 and multiply by 8. 8 times 8, 64. 8 times 1, 8. 8 plus 6, 14. 324. Units place is 4. 19 times 19. So 190 multiplied by 9. 9 times 9, 81. 9 times 1, 9 plus 8, 17. 361. And the units place is 1. 20 times 20, you get 400. That's 0. So we did up to 20, all square numbers. Now look at the units place number. You get 1, 2, 3 not there, 4, 5, 6, 7 is not there, 8 is not there. So we'll look at the previous one is also 2, 3, 7, 8 is not there. So what you observe from this? By looking at the table above, you can see that the final digit, that means units place digit of the square numbers are 0, 1, 4, 5, 6, 9. If the final digit is one of the digits, 2, 3, 7, 8, then it is not a square number. So you need to remember this. If the last digit is either 2, 3, 7, 8, that means these are not square numbers. Now look at this one. You have given 32 squared. And you can look at the last digit. 2 is the units place number here. 2 squared is 4. So when you square it, you get 4. So 2 times 2 equals 4. 3 is there. 3 times 3, you get 9. What about this one? 6 is the units place number, last digit. Here 6 into 6, 36. So here last digit is 6. Here 7 is there. 7 times 7, 49. So what's the last digit here? 9. So the digit in ones place of the number that is squared is the same as the digit in ones place of the square number. Now we can clearly see that when you square it, you get the last digit here as the answer. Select the perfect square numbers from the following digits and underline them. So what we observed so far, if the last digit is 2, 3, 7, 8, those are not square numbers. So we'll look at the last digit. 7 is there, so that's not a square number. Here 6, that means it's a square number. Here the last digit is 2, that's not a square number. 9 is there, that's a square number. 4 is okay, that's a square number. 1 is also okay for a square number. 7 is not a square number. So that means you can't underline, that's not a square number. 8 is also not a square number. 4 is okay, that's a square number. 3 is not a square number again. 9 is a square number and 1 is a square number. So when the last digit is 2, 3, 7, 8, those are not square numbers. Look at this one. All the numbers that has final digit as 0, 1, 4, 5, 6, 9 are not always square numbers. So look at this one. This is 0. But 200 is not a square number. So even this is 9. 199 is not a square number. What about this one? 4 is there. So 414 is not a square number. 6 is a square number normally, but this number 206 is not a square number. 1 is there, but 331 is not a square number. And here 5 is there, that's also not a square number, 115. So following numbers are not square numbers. So you need to be careful. Not only from the last digit, you have to check the previous digits as well. Question number 6. To denote the square root of number. So what's the symbol we use for square root? This symbol. Now what it means? This means square root of 4. Square root of 4. What is this means? Square root of 9. This one, square root of 25. Then if the number is a, square root of a. Now this is given. How you write as a symbol? Square root of 16. So you can write this symbol with 16. Square root of 16. Square root of 81. I can write this symbol. Square root of x here like this. Inside you can put the number. So now you know how to write down the square root symbol. Find the square root of a number using prime factors. Now we know what's a square number. So the reverse of square is called square root. Now we'll use prime factors to identify the square root. So what's 4? 4 you can divide by 2. Again you can divide by 2. So how can you write down 4? I can write down that's 2 times 2. So 2 times 2 I can write as a square term, 2 squared. Now the reverse process of square is square root. So the square root sign and the square term get cancelled out and you get the original value. So 2 times 2 is 4. Square root of 4 is 2. So this square root and this symbol get cancelled out. Square root symbol with the square term. Now we'll look at 16. How can we write down 16? Divide by 2, you get 8. Divide by 2, 4. Divide by 2, 2. And divide by 2, 1. So how many pairs are there? You get 2 squared and another 2 squared. Now if you want the square root, what happens? The square of that number get cancelled out with this square root and you get 2 times 2. So here square and square root, you get 2 here, and here also you get 2. 2 times 2, you get 4. You can do the same question in a different way, but without prime factors. Now, if you are asked to write down prime factors, this is the correct method. But if it's not, you can do 16, you can divide by 4. 4 times 4, 4 times 1. So, you can write as 4 squared. 16 is 4 squared. Now, you can see square root and square term get cancelled out. You get 4. So, you are not getting marks if you are asked to write the answer in prime factors. You have to do in this way, not with the other method. Both of these methods can be used to find the square root of 16. Now take this one, 25. How can we find out the prime factors? Divide by 5 and 5. So you can write 5 square and square root. So square root and square term get cancelled out. You get 5. 36. How can we write 36? I'll take 36 here. Divide by 2, you get 18. Divide by 2, 9. Divide by 3, 3. And divide by 3 again. So you get 2 pairs. 2 squared and 3 squared. And when you take the square root, what happens? You get 2 and 3. So 2 times 3, you get 6 as the square root value. It is better to use a number instead of a number pair divided by prime factors. So here, without using this, I can write this way as well. Now here, I can take this one as after this method. After writing this one, I can write the same thing as this whole thing square. So you get 6 squared. So 6 squared square root is 6. So either this way or this way you can use to find out the square root value. Now take 100. So how can we divide 100? Divide by 2, get 50. Divide by 2 again, 25. Divide by 5, you get 5. Divide by 5 again, you get 1. So you can write 2 squared and 5 squared. And when you are taking square root, you can take 2 squared with the square root, you get 2. 5 squared with the square root, you get 5. 2 times 5, 10. 144. Divide by 2. 2 again. Divide by 2 again. 2 again and 3 and 3. When you take pairs, what you get? You get 2 squared and another 2 squared and 3 squared. When you take square root, 2, 2, 3. So 2 times 2, 4. 4 times 3. Square root of 144 is 12. Find the square root of the following numbers. Now already given pairs. So how you take the square root? You get rid of this square term. 2 here, 2 here and 7. So what's the answer? 2 times 2, 4, 4 times 7, 28. This one already square term is there, so it get cancelled out with the square root symbol. So you get 3, 5, 7. 5 times 3, 15. 15 times 7, 105. This one, square terms already there. This becomes 3, 3, 5. 3 times 3, 9. 9 times 5, 45. This one, square root of this one, you get 7 and 9. 9 times 7, 63. All these numbers, the square term given. So it get cancelled out and you can write 5 and 11. So 55 is the answer here. This one, 3 squared, 5 squared, 11 squared. So 3, 5, 11. 5 times 11, 55. 55 times 3. 15 plus 1, 16. So 165 is the square root value. This one, square root of this whole thing square. So this squared and this square root get cancelled out and you get 2 times 3 times 5. So 6 times 5, 30. And look at this one. Square term and square root get cancelled out. So you get 3 times 7 times 11. So 7 times 11, 77. Multiplied by 3, 231. This one, square term is already there. So square term and this one get cancelled out. You get 7 into 11, that's 77. Here A and B. So when you take the square term out, A and B, you get AB is the square root of that. This one again, square terms are there, you can take separately. 2 here, x from here, y from there. So 2xy is the square root of that expression. Now look at this one. Square terms are there, 3a and b. You can write 3ab as the square root value. Find the square root of the following numbers using prime factors. So prime factors means you have to divide and see what are the pairs of numbers. 324 you can divide by 2. 1 here, for 12 that's 6, 2. Again divide by 2, you get 8 and 1. All prime numbers you have to take. So divide by 3. 3 times 2, 6 and 7. Again divide by 3, 9. Divide by 3 again, 3. And divide by 3 again, you get 1. So how many pairs are there? This one, this one, this one. So you can write 2 squared, 3 squared and 3 squared. Take the square root. Now what happens? Square term get cancelled out with the square root sign. So you get 2 times 3 times 3. So 3 times 3, 9. 9 times 2, 18. So square root of 18. Square root of 324 is 18. Look at this one. 400. Divide by 2. You get 200. Divide by 2 again, 100. Divide by 2, 50. Divide by 2, 25. Now divide by 5. You get 5, 1. Now pair up the prime factors. You get 2 squared. 2 squared there and 5 squared. And when you take the square root, You get 2 times 2 times 5. 2 times 2, 4. 4 times 5, 20. This one, divide by prime numbers. Divide by 2. 288. Divide by 2 again. 144. You get 72. 36 and 18 and 9. Divide by 3, you get 3 and 1. When you pair up the prime factors, you get 2 squared, 2 squared, another 2 squared and 3 squared. And when you take the square root, all the square terms get cancelled out. You get 2, 2, 2 and 3. 2 times 2, 4. 4 times 2, 8. 8 times 3, 24 is the square root of 576. 625. What's the square root value? Divide by 5. 5 times 1, 5 times 2, 10. 5. Divide by 5 again. Divide by 5 again and divide by 5. You get 1. So, what are the numbers? 5 squared and 5 squared. And when you take the square root, you get 5 times 5. That's 25. So, square root of 625 is 25. Now this one, 484. Using prime factors, find the square root. Divide by 2. Divide by 2 again. Now you can divide by what? 11. 11 is the prime factor. 11 times 11 is 121. Again, divide by 11, you get 1. So what are the prime factors? 2 squared and 11 squared, and take the square root. So you can write 2 times 11 as 22. So square root of 484 is 22. This one, 900. Divide by 2. You get 450. Divide by 2 again. 225. Then divide by 3. 7 and for 15, that's 5. Now divide by 3 again. 3 times 2, 6. And for 15, that's 5. Divide by 5, you get 5 here. You get 1. So pair up the factors. Here you get 2 squared, 3 squared and 5 squared. And when you take the square root, you get 2, 3, 5. 3 times 2, 6. 6 times 5, 30. So square root of 900 is 30. Look at this one, 361. So we can divide by 19. 19 is a prime factor, not 2, 3. It doesn't work. So 19. So 19, when you divide, you get 19 there. So we'll see 19 times 19. 9 times 9, 81. 9 times 1, 9. 9 plus 8, 17. So you get 6 and 3, 361. So 19 times 19. So you can write 19 squared and take the square root. So this is 19 is the answer for square root 361. And 529 also, you can't divide by 2, 3 like that. So when you take 23, you get 23. So 23 times 23, you get 529. So 23 times 2 is 46. 46 and you get another 69. 69 means 3. So 23 squared. So 23 squared and square root You get 23 as the answer. By observation, find the square root of the following perfect square. Now we are using a different method by observing. So 1 squared is 1. What's the last digit here? That's last digit here is 1. So square root of 1 is 1. 9 squared is 81. Now reverse is this. What is square root of 81? This is 9. We know 11 squared is 121. Square root of 121 is 11. 19 squared is 361. Square root of 361 is 90. Square of 21 is 441. Square root of 441 is 21. Now look at the last digit. Last digit in the answers is number 1 or 9. Here. If the last digit of the number to be found in the square root is 1. See, last digit is 1. Then the last digit of the answer is always 1 or 9. So, why this happens? We know that 1 times 1 is 1. Or 9 times 9, you get 81. So, the last digit is 1. So, what are the possible instances you get last digit 1 as the answer? Either you can get 1 or 9. So, remember this, it's really important when you are finding the square root. 1 or 9, you are always getting ones there. Look at this one. 2 squared is 4. Square root of 4 is 2. 8 squared is 64. Square root of 64 is 8. 12 squared is 144. Square root of that is 12. Here always reverse. Reverse is this is 18 and reverse of 484 square root is 22. Now observe the last digit in the answers. Either 2 or 8. What about this one? In the question, always the last digit is 4. If the last digit of the number to be found in the square root is 4, then the last digit of the answer is always either 2 or 8. So why this happens? We know 2 times 2, you get 4. Or 8 times 8, we get 64. So now can you see? You are getting 4 either with 2 or 8. Look at this one. 5 squared is 25. What's the square root of 25? That's 5. Here, square of 15. Here, there's an easy way to find out square terms. We know 5 squared is 25. 15 squared. 15 times 15, when you multiply, you will get 225. 25 times 25, you will get 625. Now look at this pattern. When you multiply by last digit 5s, that means square terms, you get always 25 as the last 2 digits. So how you get the previous one? Previous one is always multiply this number with the next number. How you get 2 here? 1 times 2. How you get 6 here? 2 times 3. So how you get here nothing there? That means you don't need to multiply there. So then what about 45 squared? You get 25 and 4 times 5. You always multiply the next digit. 4 times 5, 20. So it becomes 2025. So we'll use that method. What is 15 squared? 225. So square root of 225 is 50. 25 squared is 625. Square root of 625 is 25. 35, use that method. 25, 3 times 4, 12. So 1225 square root is 35. 45 squared, 25 comes 4 times 5, 20. 2025 square root is 45. Now observe the last digit. If the last digit of the number to be found in the square root is 5, then the last digit of the answer is also here always 5. This is 5 here. This is 5. So in this case, 5 times 5, 25. So you get only with 5, the last digit 5. I'll write this in blue. Now we'll take this one. Observe 6 squared is 36. Square root of 36 is 6. 14 squared, multiply 14 times 14. That's 4 times 4, 16. 4 times 1, 4 plus 1, 5. 196. Square root of 196 is 14. Then 16 squared. 6. So 256. And square root of 256 is 60. 24 squared. 20 and 4. And 16. 4 times 2, 8 plus 1, 9. 576. Square root of 576 is 24. 26 squared. 20 and 6. 5. 6 times 6, 36. 6 times 2, 12. 12 plus 3, 15. So you get 676. So square root of 676 is equal to 26. Now what you observe? If the last digit of the number to be found in the square root is 6, then the last digit of the answer is always 4 or 6. So look at this one, 4 or 6, and here the last digit is 6. So what you observed here, that means 4 times 4, you are getting 16. So the last digit is 6, or 6 times 6, 36. The last digit is 6. Now another example. Observe what you get. 3 squared is 9. Square root of 9 is 3. 7 squared, you get 49. And square root of 49 is 7. 13 squared, you get 169. Square root of 169 is 30. Reverse of square is square root. 17 squared, multiplied by 17. 7 times 7, 49. 7 times 1, 7 plus 4, 11. So you get 289. Square root of 289 is 17. 23 times 23. What you get? 4, 3 times 3, 9, 3 times 2, 6. 529. So 529 square root is equal to 23. Now observe what you get. If the last digit of the number to be found in the square root is 9, then the last digit of the answer is always 3 or 7. So how you get? 3 times 3, you get 3 times 3, 9, or 7 times 7, 49. So the last digit you get 9 either for 3 or 7. This one, 10 squared is 100. Square root of 100 is 10. 20 squared is 400. Square root of 400 is 20. 30 squared is 900. Square root of 900 is 30. 40 squared, so you can do 4 times 4, 16. So 1600. Square root of 1600 is 40. 50 means you can put 5 and 5, 25, and put 2 zeros, 2500. Square root of that is 50. Now, if the last digit of the number to be found in the square root is 0, then the last digit of the answer is always 0. Here, observe that. This is 0. Here also 0. So 0 times 0, only you are getting 0. Now, we observed several digits, the last digits when you multiply. So where you get 0? Only when it's 0. 5, only when you get 5. So 0 and 5, only one digit. 0 times 0, 0, and 5 times 5, 25. So you get 5 there as the last digit. Where you get 1, either 1 or 9. 9 times 9, 81. Where you get 4, 2 times 2, 4, or 8 times 8, 64. Then 6, 6 times 6, 36, and 4 times 4, 16. That's 4. 4 or 6. Then 9, 3 times 3, 9, and 7 times 7, 49. So you need to know this to find out the square root of a number. Now we'll try to find out square root of these hundreds places numbers, 441. So this is easy. So you look at the first hundreds place number, square root of 4. What's that? 2. Look at the last digit, 1. Square root of 1 is 1. So what are the numbers you can get? So here square root of 1 is always 1. Square root of 4 is 2. So this means 21 times 21 is 441. So you can check whether this is 21. So we'll multiply 21 times 21 and see. 1 times 1. So when you add it, you get 441. So the answer is 21. Look at this one. Square root of 9, that's 3. Square root of 1, that's 1. So what should be the square root value? 31. We'll check it. 31 times 31, 30 and 1. You get 961. So that's correct. So I'll write down this one is 21. This is 31. Now this one, 169 square root. Square root of 1 is 1. Square root of 9 is 3. So what's the answer? 13. We'll check it. 13 times 13. 3 times 3, 9. 3, you get 169. So that's correct. So how you find out the square root of these numbers? Hundreds places. So square root of that and the square root of the units place. Finding square root when the digit in the hundreds place is not a square number. Now earlier we did square numbers in the hundreds place. Now it's not a square number. 5 is not a square number. So we'll see how we find out the square root. Square root of 5. So we take the lowest square number. Close to 5, what's the lowest one? Square root of 4. So less than 5 you have to find. Square root of 4 is 2. What is 6? Last digit is 6. How you get last digit 6? Tell me, according to the table. Either 6 or 4. So 4 or 6. 4 times 4, 16. 6 times 6, 36. Now, it can be either 24 or 26. So we need to check which number is correct. Now I'll give you an idea. Now we know square numbers. 25 times 25 is 625. This is less than that, 625. So what do you think? The number should be less than 25 or greater than 25? The number is less here. So that means we assume that this is the correct answer. We'll check it out. 24 times 24. 20 and 4. You get 576. And when you take 26 times 26, that should be more than 625. So 20 and 6. And 6 times 6, 36. 6 times 2, 12. 12 plus 3, 15. So you get 676. Now see, the correct number is 24. So square root of 576 is 24. If you know the square numbers, you can easily find out the correct value without multiplying all these. 625. So what's the lowest square number below 6? Less than 6. Square root 4. That's 2. What about here? Where you get 5 as the last digit? Only possibility is 5. So what's the answer? Square root of 625 is 25. So 25 times 25 is 625. This one. Square root of 7. So what's the lowest one? Square number. That's 4. So square root of 4 is 2. Where you get 4 as the last digit? What are the possibilities? Either 2, 2 times 2, 4, or 8. 8 times 8, 64. So the numbers are either 22 or 28. Now how you identify that? Which one do you think? We know 25 times 25 is 625. This is more than 25 because this is 784. So definitely the correct answer should be 28. We'll check that one. So 28 times 28. 28 times 28, 20 and 8. 64. And 8 times 2, 16 and 22. 784. So that's the correct answer. So what's the square root of 784? That's 28. Then this one, square root of 529. So what's the square number less than that? That's 4. Square root of 4 is 2. How will you get 9 as the last digit? Either 3 or 7. 7 times 7, 49, or 3 times 3, 9. So either you need to get 23 times 23 or 27 times 27. Now what's the method? We know 25 squared is 625. So this number is less, 529. That means the number should be less than 25. So this should be the number. We'll check it. 23 times 23. 3 times 3, 9. 3 times 2, 6. You get 529. So that's the correct answer. Look at this one. Square root of 841. So what's the lowest square number here? Less than 8? Square root of 4. That's 2. 1. How you get 1? Either from 1 or 9. 9 times 9, 81. So it can be either 21 or 29. Now what do you think? What's the closest square number? 20 times 20, 400. So 841. So 21 is close to 400, very close. But this is 841 means definitely this should be this one. So we'll check 29 times 29. And here 9 times 9, 81. 9 times 2, 18. And 8, 26. So 1. So 841. So that's the correct answer. So what is the square root of 841? That's 29. This one. Square root of 729. So what's the lowest value here? Less than 7 square number is square root 4. That's 2. How you get 9? 9 you get either 3. 3 times 3, 9. Or 7 times 7, 49. 7. So what are the two possible numbers? Either 23 or 27. So which one is suitable? We know 25 times 25 is 625. This is more than 625. So that means more than 25. So the correct answer should be 27. So 27 times 27, we'll check it. So 27 times 27, 20 into 7, you get 14, 5. 7 times 7, 49. And 7 times 2, 14 plus 4, 18. So the final answer is 729. So that means the correct answer is 27. 7. So square root of 729 is 27. Now look at this one. Show that this is not a perfect square number. So what you do? Use the same procedure. What's the lowest value here? 7 is there. What's the closest square number less than that? 4. Square root 4. That's 2. 9. How you get 9? Either 3 or 7. 7 times 7, 49. So two possibilities are there. Either 23 or 27. Now this is not a square number, so we need to multiply and show that this is not 749. So 23 times 23, you get 529. So that's not this number. 27 times 27, 20 and 7, you get 9, 12, 7, 729. Now see, 749 is not a perfect square number. Is not a perfect square number. Find the square roots by observing digits. What's the value? Square root of 1 is 1. Square root of 4 is 12. So square root of 144 is 12. This one, both square numbers, 100 digit as well as the units place. So square root of 1 is 1, square root of 9 is 3. This one, 25, here 225. This one is not a square number. So what's the closest value? Less than that is 1 and 5. Where you get 5? Only possibility is 5. 5 times 5, you get 25. This one, 2 is there. 2 is not a square number, but we take the lowest values. Lowest square number is 1. And 6. What are the possibilities to get 6? Either 6 times 6 or 4 times 4. So you need to decide whether this is 14 or 16. Now what's the method? 225 for 15. 15 squared is 225. Now this number is larger than that. So definitely this should be 16. This one, 289. What's the square root value here? Less than 2, that's 1. You get 1 here. 9, you get either 3 times 3 or 7 times 7, 49. So either 13 or 17. Which one is correct? What's the closest value we can take? 15. 15 is 225. This is more than that. So that means definitely this should be 17. Square root of 324. What's the lowest value here? Square number. Less than 3, that's 1. 1 square root is 1. 4. What are the possibilities to get 4? 2 or what's the other number? 8. So this should be either 12 or 18. Which one is suitable? We know 15 times 15 is 225. So this is more than that. This should be 18. 361. Lowest value here, less than 3, the square root value is 1 square root, that's 1. 1. How you get 1? Either from 1 or 9. So the two possibilities are 11 or 19. How you identify? 12 times 12, 144. This is more than that. So definitely this should be 9. We can check. If you are not sure, you can check it. 19 times 19, you get 81. 9 times 1, 9 plus 8, 17. So 1, so 361. That's 90. 400 square root, both are here. 4 square root is 2 and 0 square root is 0. This one, square root of 4 is 2. Square root of 1 is 1. If it's a square number, you can straight away find out the square root value. Square root of 4 is 2. Square root of 4 is 2. Here, this is not a square number, so you have to take the closest one. Square root of 4 is 2. And 9, how you get 9? What are the possibilities to get 9? Either 3 or 7. So 27 or 23. So which one is suitable? 25 times 25 is 625. This is less than that. So 23 is the correct answer. 900, square number. So square root of 9 is 3. Square root of 0 is 0. So 30 is the number. Look at this question. Find the area of ABCD square. So this is a square. So how you find out the area? Length into width. So 9 centimeter square. This is another square. Find the area of PQRS. That's 4 times 4. 16 square centimeters. Now we'll look at the next part. It's another square. Find the area of KLMN. Length side is x. So what's the area? X into x. That means x squared. That's also, I think, square centimeters, because it's not given, but to find out the relationship, you need to get the same units. If the area of the square of KLMN is equal to the sum of areas of squares ABCD and PQRS, then find the relationship between x squared, 9 and 16. So we found out area of KLMN is x squared. And what's the area of the previous? What's the area of the previous two squares? 9 and 16. So we can add 9 and 16. So that's the relationship between x squared, 9 and 16. According to the above, determine the value of x. We know x squared is 9 plus 16, you get 25. So how you find x? You have to take the reverse of that. So square root of 25. So what is square root of 25? That's 5. So what's the answer? Answer is 5. This is in centimeters. So 5 centimeters should be the length of the side. Find the value of a if a squared is 6 squared plus 8 squared. So 6 squared is 36, 8 squared is 64. When you add these two, you get 100. So how you find out a? Square root of 100. Square root of 100 is 10. Or you can write 10 squared as 100, and then square root and square term get cancelled out. This one, 5 squared is 25. 12 squared is 144. When you add these, you get 169. So 169 is 13 squared. 13 times 13. When you take the square root, you get 13 as the y value. Find the square root of the following numbers. So we'll write as square terms. 4 is 2 squared. 9 is 3 squared. So when you write square term, you can write this as 2 times 3. So 2 times 3 is 6. 9 you can write 3 squared. 25 is 5 squared. When you take the square root, it's 3 and 5. That's 15. 36 is 6 squared. 49 is 7 squared. When you take the square root, this is 6 times 7, 42. 25 is 5 squared. 49 is 7 squared. So when you take the square root, this is 5 times 7, 35. This one. So we'll write separately the numerator and the denominator. Here all are fractions. 9 is 3 squared. 16 is 4 squared. When you take the square root, this is 3 and 4. 25 means 5 squared. 36 is 6 squared. When you cancel out this square root with square term, you get 5 over 6. This one, 36 is 6 squared. 25 is 5 squared and 9 is 3 squared. When you take the square root, this is 6 times 5 over 3. 3 times 1, 3 times 2. So finally you get 10 as the square root value. Square root of 4 is 2. That means 2 squared. 81 is 9 squared. And 36 is 6 squared. When you take the square root, you get 2 and 9, here 6. So 3 times 3, 3 times 2. So 2 and 2 get cancelled out. The final answer is 3. This one you can do here. Square root of 25, you know that's 5. So 4 plus 5, 9. Square root of 9 is 3. You can start from here. Square root of 144, 12. 37 minus 12, you get 25. Square root of 25 is 5. This one you can do separately. Square root of 16 is 4. Square root of 25 is 5. 4 plus 5, 9. Square root of 9. Or you can write 9 as 3 squared. And then what's the square root? You get 3. Square root of 100, that's 10. Square root of 36, that's 6. 10 minus 6, 4. Square root of 4, I can write 2 squared and take the square root. The answer is 2. Now we'll look at example 1 in your textbook. A square tile is of side length 8 centimeters. Show that the numerical value of its surface area is a perfect square. So this is a square tile with length 8 centimeters. So what's the surface area? So surface area of a square tile. So 8 times 8. So 8 times 8 is the surface area. So I'll write down surface area. Surface area means the upper surface. 8 times 8, that's 64 square centimeters. And it says show that the numerical value is a perfect square. So how you identify a perfect square? So here we can see 8 is the row length, This is the column length. Both are equal. So that's why this is a square number. So you can write 64 is a square number. Square numbers are perfect squares. Square numbers are perfect squares. Exercise 8.1. Represent the square of 5 by an arrangement of dots and write down its value. A square of 5 by 5. So this is 1, 2, 3, 4, 5. So row length is 5 and the column length is 5. One, two, three, four, five. 1, 2, 3, 4, 5. Another one. So 5 by 5. So this is the square. And write down its value. So 5 into 5 altogether 25. So 5 squared is 25. Complete the table given below and answer the questions accordingly. Number and square of the number. So square of the number 1 squared is 1. 2 squared 4. 3 into 3, 3 squared 9. 4 times 4, 16. 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. 8 times 8, 64. 9 times 9, 81. 10 times 10, 100. 11 times 11, 121. 12 times 12, 144. 13 times 13, 169. And what is 14 times 14? 4 times 4, 16. 4 times 1, 4 plus 1, 5. 196. 15 times 15, 225. 16 times 16. 6 times 6, 36. 6 times 1, 6 plus 3, 9. 256. So what about 17 times 17? 7 times 7, 49. 7 times 1, 7 plus 4, 11. 289. 289. So those are the square numbers. By adding some pairs of perfect squares in the second row, we can obtain another perfect square. Observe the table and write 4 such relationships. 9, 16, 25. So that means 3 squared and 4 squared is 5 squared. So what else? What are the other relationships you can get? Identify. 9 and 16 did. 64, can you make 64? 36 with 16? No. 100? 100 is 64 and 36. So these two, you get 100. So that means 6 squared and 8 squared. 6 squared and 8 squared is 10 squared. What else? 121. 144. Can you make 144? 21 with, no, 81 with 169, 13. You get 144 and 25. These two. You get 169. So what are the square numbers? 5 squared and 12 squared. You get 13 squared. Now observe. Now here when you take multiples, you can see that. So multiplied by 2, you get this. Multiplied by 3, you can find the other pair. 3 times 3, 9. 3 times 4, 12. 3 times 5, that should be equal to 15 squared. So 9 squared is 81. 12 squared is 144. When you add it, you get 225. So we need to find another pair, but this is not sufficient. When you consider multiples, if you multiply by 4, you get 12 squared, 16 squared. That should be equal to 20 squared, but it's not there. But we know 20 squared is 400. We'll check. 12 squared is 144 and 16 squared is 256. When you add it, you get 400. That's 20 squared. Question number 3. Write down the perfect square between 10 and 20 and the reason for it. So square numbers are length into with same square. So in between 10 and 20. So 3 times 3, 9. 4 times 4, 16. So 4 squared is 16. So what's the reason there? We can write number of rows is equal to number of columns, because this is a square. Second part, write down the perfect square between 60 and 70. 8 times 8, 64. So 64 is a square number. Here also number of rows is equal to number of columns. Third one, write down the perfect square between 80 and 90 and reason for it. 9 times 9, 81. That's also number of rows is equal to number of columns. Then fourth one, how many perfect squares are there between 110 and 160? So you get 11 times 11 is 121. 10 times 10, 100. So more than 10. So 11 times 11, 121. 12 times 12, 144. 13 times 13, 169. So only 2 numbers are there. Question number 4. Complete the table given below. 1 is this. This is sum the perfect square in index form. 1 is 1. So that's 1 square. 1 plus 3, 4. That's 2 square. 1 plus 3 plus 5, 9. That's 3 square. What's the value here? 4, 4 plus 5, 9. 9 plus 7, 16. That's 4 squared. And here 16 plus 9, 25. That's 5 squared. Using the above table, write the special feature of the numbers that are obtained when consecutive odd integers starting from 1 are added together. So what's the property? You are getting square numbers. So when you add numbers, integers like this, these are odd numbers. When you add odd numbers, you are getting square numbers. So you can write adding consecutive odd numbers we get square numbers. Example number 1. Is 272 a perfect square? What do you know from the last digit? Ones place, when you get 2, 3, 7, 8, these are not perfect square numbers. So here you can write last digit is 2, therefore 272 is not a perfect square. Exercise 8.2. By considering the digit in the units place of each of the numbers given below, show that they are not perfect squares. So last digit is 2. Last digit is 2, therefore not a perfect square. Yeah, last digit is 7. Last digit is 7, therefore not a perfect square. (513) is also not a perfect square. Last digit is 3, not a perfect square. Question number 2. Give an example of a perfect square which has 9 in its units place. So how you get 9 in the units place? You can get 3 and what are or 7. So 7 times 7, 49. 3 times 3, 9. So you can get 13 times 13 or 17 times 17. So you get last digit 9. So give an example of a perfect square. So 13 times 13, you get 169. Question number 3. If the digits in the units place of a whole number is 1 of 0, 1, 4, 5, 6 or 9, then it is a perfect square. Show with an example that this statement is not always true. So we'll take last digit 0, 1, 4, 5, 6, 9. So we know that 10 is not a perfect square. And if we take 1 here, 21 is not a perfect square. With 4, that's 54, is not a perfect square. With 5, we'll take 115 is also not a perfect square. With 6, 126 is not a perfect square. And with 9, we'll put any number 159. It's not a perfect square. Question number 4. Observe the digit in the units place of each number given below and write the digit in the units place of their respective squares. So that means 34 squared. Now 4 squared is there. So what's the last digit? 6. Because 4 into 4, 16. So 6 is the last digit. What about this one? 68 squared. So 8 times 8, 64. So 4 is the last digit. Third one, 45 squared. So 5 times 5, 25. So 5 is the last digit. Example number 1. Find the value of root 576 using prime factors. So we'll do that. 576. Divide by 2. Again 288. Divide by 2 again, you get 144. Divide by 2, 72. Divide by 2 again, 36. Divide by 2, 18. Divide by 2, 9. Divide by 3, 3 here, 3. So here, take pairs of numbers. Here you get 2 squared, 2 squared, another 2 squared and 3 squared. When you take the square root, what you get? Square and the square root get cancelled out. You get 2 times 2 times 2 times 3. 2 times 2, 4, 4 times 2, 8, 8 times 3, 24. So 24 is the square root of this value using prime factors. Exercise 8.3, find the value of each of the following. So square term is there. When you take the square root, it gets cancelled out and you get 2 times 5, that's 10. This one, square term is there. So you can take the square root is 2 times 3 times 5. So 2 times 3, 6, 6 times 5, 30. This one, you can write this one as 3 times 5. Twice is there, that means square term. And then when you take the square root, it gets cancelled out and you can take 3 times 5, that's 15. This one, you can write as 3 squared and 7 squared here. When you take the square root, you get 3 and 7, 21. This one you can write 2 squared, 3 squared and another 3 squared. When you pair up these numbers, when you take the square root, it gets cancelled out and you can write 2 times 3 times 3. 2 times 3, 6, 6 times 3, 18. Find the square root using prime factors. So take the number, divide by prime numbers. You get 72. Divide by 2, 36. Divide by 2, 18. Divide by 2 again, 9. Divide by 3, you get 3. So when you pair up the numbers, you can write this one as 2 squared, another 2 squared and 3 squared. When you take the square root, you get 2, 2, 3. 4 times 3, 12 is the answer. 400. Use prime factors. Divide by 2. Divide by 2 again. 2 again 50. 2 again 25. 5 again. You get 1. Now pair up the factors. You get 2 squared, another 2 squared and 5 squared. When you take the square root, you get 2 times 2 times 5, 4 times 5, 20. So square root of 400 is 20. 900. Divide by 2. Divide by 2 again. Divide by 5. Divide by 5. And again divide by 3 and 3. So when you pair up the factors, you can write as 2 squared, 5 squared and 3 squared. When you take the square root of 900, 2 times 5 times 3. 10 times 3, 30. 325 square root value. So take 2 and divide. 2 times 1, 2, 6, 2. 2 times 8. Then 3. 3 times 2, 6. And 7. 3 times 9. Again divide by 3. You get 1. When you take pairs, you get 2 squared, 3 squared and another 3 squared. When you take the square root, you get 2, 3, 3. 6 times 3, 18 is the answer for square root 324. 625. 625 divide by 5. 125. Divide by 5 again. 25. 5 again, you get 5. So you get 2 pairs. So 5 squared and 5 squared. When you take the square root, you get 5 times 5, that's 25. 484. Find out the factors. 484. Divide by 2. Divide by 2 again. Divide by 3. You can't divide by 3. You can divide by 11. 11 times 11 is 121. So when you pair up this, you get 2 squared and 11 squared square root. So 2 times 11, that's 22. What is the side length of a square-shaped parking lot of area 256? So that means finding the square root of that. Square root of 256 is the side length. So we'll take this one is x and this one is x. So I can write x squared is 256. So what's x? Square root of 256. We'll use prime factors to find out the square root. Divide by 2. Divide by 2 again. 2 again, you get 32, 16, 8 and 4. Another 2 there. You get these numbers when you pair up. You get 2 squared, another 2, another 2, 1, 2, 3, 4. 4 pairs of 2's. So when you take the square root, you get 2 times 2 times 2 times 2. 4, 4 times 2, 8, 8 times 2, 16. So what's the length? What is the side length? 16 meters because this is given in square meters. Question number 4. The area of a square land is 169 square meters. Find the length of a side of the land. This is also a square. We'll put x and x. The area x into x is equal to 169. So x squared is 169. How you find x? That means square root of 169. So we'll use prime factors to find out the square root. Divide by 13. 13 times 13 is 169. So you can write 13 square. When you take the square root, that's 13 meters. This is an activity. Complete the table given below by considering the perfect squares you have identified so far and their square roots. Perfect squares with digit 1 is given here. Perfect squares with the digit 4 in the units place. So what are the numbers? 4, 24, it's not 34, 44, 54, 64, 74, 84, 94, 104, 114, 124, what else? 134, 144 is a square number. So what's the other number? So you have to multiply and see. So you need 4 there. So when you take 324, it's another square number. What about another one? 484 is another square number. Now square roots of these perfect squares. Now find out square roots. 2, 8, 12. So what's the square root of this? 324 is 80. What about 484 square root? When you find out square root, you get 22. Now look at the next one. Perfect squares with the digit 5 in the units place. So what's the first one? You get 25. How you get another value with digit 5 in the last place? 225 is also a square number. And what else? 625 is also a square number. Now try out some more values. 1225 is also another square number with last digit 5. And 2025 is also a square number. Now find the square root of those. 25 square root is 5. 225 square root is 15. This one is 25. 1225 square root, what's that? 35. And this one is 45. Now do the next one. Last digit as 6. What's the first number? 16. Then 36. What's the next one? 196. Then when you count, you get 256. What about the next one? You get 576. So what are the square root values there? Square root of 16 is 4. Square root of 36 is 6. What about 196 square root? That's 14. 256 square root? That's 16 times 16, that's 16. What's the square root of 576? You get 25. Now, perfect squares with the digit 9. What are the numbers? 9 and then 49, 169. What else you get? Count and see. 289. Then what's the next number you get? 529. When you take the square roots, you get 3 here, 7 and 13 for 169. So what's this one? 289, 23. And what about the square root of 529? That's 29. Then perfect squares with the digit 0 in the units place. So what's the first number? 100. Then 400. What else? 900 you are getting. Then 1600 and 2500. When you take the square root values, you get 10, 20 times. So here 20, 30, 40 and 50. So you have to try out all these square numbers. So this is an activity for you. Complete the table given below using the information in 1 to 6 in the above table. So here they are asking to look at the values here and identify the pattern. But we know what are the numbers getting. If the digit in the units place of the perfect square 145690, what are the digits in the units place of the square root? Can you remember? 0 is definitely 0. Only 0 times 0 you get 0. And 5 also, only 5 you are getting when the last digit is 5. What about 1? 1 you can get 1 times 1 and 9 times 9, 81. So that's 1 there, 1 and 9. What about 4? You can get either 2 or 8 times 8, 64. So you get 2 or 8. 6, 36 or 16. 16 means 4 times 4 or 6 times 6, 36. 9, how you get? 3 times 3, 9 or 7 times 7, 49. So 3 or 7. Example number 1, find square root of 961. So we'll use the method we did by looking at the 100 place value and the units place. So we take square root of 9. That's a square number. That's 3. So 1's place, square root of 1 is 1. So what's the number? Square root of 961 is 31. So 31 times 31 is 961. We can check it. 31 times 31, 3 with 30 with 1, 3 times 1, 9, and you get 961. So square root of 961 is equal to 31. Example number 2. So here, how you find out square root of 625? So this is not a square number here in hundreds place. So what you do? Take the number, square number less than that. What's the square number less than 6? Square root of 4. That's 2. 5. How you get 5 as the last digit? Only with 5. So what's the square root of 625? That's 25. 25 times 25 is 625. Example number 3, 784. So look at the hundreds place value. What's the square number less than that? 7 is the number, 4 is the square number less than 7. So square root of 4 is 2. 4. Where you get 4? Either 2 or 8. You get last digit as 4. Now what are the possibilities? You can get either 22 or 28. Now how you decide which number is suitable? Now I told you take a closest value. So 25 times 25, it's a square number, that's 625. This number is more than that, 7. So definitely above 25, that should be 28. So we'll check it. 28 times 28, that means 20 and 8. So you get 64. 8 times 2, 16 plus 6, 4, 8, 7. 784. So that's the answer. So what's the square root of 784? Answer is 28. So you are getting the same question in example 3. Here I'll use a different method. So using multiples of 10, I can write 784 is in between. What are the two square numbers? In between 400 and 900. Then what's the square root of 400? That's 20. This one 30. Square root of 900. So square root of 784 should be in between 20 and 30. But we know that last digit is 4. So what are the possibilities of getting 4? Either 2 or 8. So the two possible numbers are 22, that's in between 20 and 30, and 28. So 22 times 22 or 28 times 28. Then you can check with the number that we know already. 25 times 25 is 625. So this is more than that. So definitely this should be 28. So this is another way of finding square root value. So 28 times 28 is 784. So what's the square root of 784? That's 28. Example number 4. Show that 836 is not a perfect square. So how we identify it's not a perfect square? We'll use the same method. What's the square number less than this? That's square root 4. You get 2. How you get 6 as the last digit? You get 4 or 6. Now what are the possibilities you can get? You can get either 24 or 26. Those are the two possibilities you can get for a square number. So we'll multiply and see what's the number you are getting. So if it's not a perfect square, you get different answers here. So we'll multiply and see. 24 times 24. Add it together, 576. And when you multiply 26 times 26, add it together, you get 676. Now say 836 is not a square number. So therefore 836 is not a perfect square. Exercise 8.4, complete the table given below. Perfect square numbers are there. Square root of the perfect square. So you can write similar to this one, 36 square root is 36 is 6 squared, and square root and square term get cancelled out and you get 6. 64 square root is 8 squared, and when you take the square root you get 8. 121 square root is, this is 11 squared. The answer is 11. 400 square root is 20 squared, square root. Answer is 20. And 900 means, square root 900 means 30 squared. And when you take the square root, that's 30. Question number 2, check whether the given numbers are perfect squares and find the square root of each number which is a perfect square. So here 169. So last digit is 9. So can be a perfect square. So square root of 1 is 1, square root of 9 is 3. So this is 13 square. So when you take 13 square and take the square root, you get square root of 169. So what's the square root? You get 13. Now look at this one. Last digit is 2. So last digit is 2 means not a perfect square. This one, 441. We can use square root of this one is 2. Square root of 1 is 1. So I can write this one as 21 square. So what's the square root of 440? What's the square root of 441? That's square and take the square root. That's equal to 21. Now what about this one? 716. Is it a square number? We have to check it. So 6 you can get either from 6 or 4. And here square root of 7, that's the closest value is square root 4. And that's 2. 24 or 26. So we'll multiply and see. 24 times 24. 576, and 26 times 26. 676. So that means 716 is not a perfect square. Now take these questions. 361. So 1 you can get either from 1 or 9. And square root value, so the closest value less than 3 is square root of 1, that's 1. So 11 times 11 is 121, 19 times 19. We'll check what is 19 times 19. 10 and 9. So you get 9 times 9, 81. 9 times 1, 9. 9 plus 8, 17. So 361. So how can you write this one? As 19 squared. So 361 square root is 19 squared. Square root, that's 19. This one 484. Square root of 4 is 2. Square root of 4 is 2. So that means 22 squared is the square value. So 484 is 22 squared. So what is square root of 484? That's 22. Here, this one, last digit is 2. That means it's not a perfect square. This one, 529. 9, how you get? 3 times 3, 9, or 7 times 7, 49. What's the square root value you can take less than 5? Square root 4. So square root 4 is 2. So this should be either 23 or 27. We'll multiply and see. 23 times 23. 529. So that means this is 23 square. Then when you want to find the square root, that's equal to 23. This one, 2 is there. This is not a perfect square. This one, 624. We'll find 4. How you get 4? Either by 2 times 2 or 8 times 8. 2 or 8. 6, what's the lowest value for 6? Less than 6, that's square root 4, that's 2. So you can get either 22 or 28. We'll multiply and see. 22 times 22. You get 484. Now we'll check with 28. 8 times 8 here, 8 times 8, 64, 8 times 2, 16, plus 6, 6, you get 22. 487, 784. So that means 624 is not a square number. Question number 3. The value of square root 324 is a whole number between 15 and 20. Find square root of 324 by observing the last digit. Okay, so what's the last digit? 4. How you get 4 there? 2 times 2, 4, or 8 times 8, 64. 2 or 8. What's the number between 15 and 20? You can get not 12, so only number is 18. So 18 is in between 15 and 20. So we'll see whether 18 times 18 you get 324. 18 times 18, 8 times 8, 64. 8 times 1, 8 plus 6, 14. you get 324. So 18 times 18 is 324. So what's the square root of 324? That's 18. 625 is a perfect square. Its square root is a whole number between 20 and 30. Find square root of 625. So we'll observe the last digit. Last digit is 5. That means definitely the number should be with the last digit 5. So in between 20 and 30, only possibility is 25. So we'll check 25 times 25. 25 times 25. 20 and 5, you get 500. And here 5 times 5, 25. 5 times 2, 10 plus 2, 12. So you get 625. So that means what's the square root of 625? That's equal to 25. Find the square root of each of the numbers given below by observation. We'll look at the number and see. 6. What's the possibility to get 6? What's the possibility to get 6? 4 and 6. This one, 2. What's the number less than that? Square number less than root 2? That's root 1. That's 1. So 14 or 16. Now we know 15 times 15, 225. This is more than 225. So what's the number should be? 16. So 16 times 16 should be 256. So what's the square root of 256? That's 16. This one, how you get 1? What are the possibilities? 1 or 9. And here 4. Square root of 4 is 2. So this should be either 21 or 29. Now we know 20 times 20 is 400. So this is close to 400. So we'll check 21 times 21 and see. So 21 and 21, you get 441. So the square root of 441 is 21. Now look at this one, 729. So how you get the last digit as 9? 3 times 3 or 7 times 7. Now when you take 7, what's the square number lower than 7? That's square root 4. That's 2. Now you can get either 23 or 27. What's the method? How you identify the value? We know 25 times 25 is 625. So this number is more than 625. So that means more than 25 means 27. We have to check it. 27 times 27 and see. 20 and 7. 14 and 5. 7 times 7, 49. 7 times 2, 14 plus 4, 18. You get 729. So what's the square root of 729? That's 27 because you get here 729. 361. How you identify? How you get 1? 1 times 1 or 9 times 981. Then when you take the first digit, what's the square number less than this? Square root of 1, that's 1. So you're getting either 11 or 19. Now how you identify? How you identify that? 15 times 15, 225. So this is more than 15. So this should be 19. So we'll check 19 times 19. 9 times 9, 81. 9 times 1, 9 plus 8, 17. 361. So this is 19 times 91. So square root of 361 is 19. Look at this one, 841. How you get 1? Either 1 or 9. 8, when you take 8, what's the square number less than that? 8 square number is 4. 4 means square root of 4, 2. So what are the possibilities? 21 or 29. 21 or 29. So we'll check 25. We know 25 times 25, 625. But this is more than that. So definitely this should be 29. So we'll check with 29. 29 times 29. 20 and 9. 580. You get 26 here. 841. So that's the answer. So what's the square root of 841? That's 29. Miscellaneous exercise. In the given figure ABCD is a square of side length 8. It's given, and BTRS is a square of side length 6. And ATPQ is a square of side length 10. Find the area of the square ABCD. So what's the area? 8 times 8. That's 64 square centimeters. Find the area of the square BTRS. Side length is 6. 6 times 6, 36 square centimeters. Find the area of the square ATPQ. That's length 10. 10 times 10, 100. Find a special relationship between the areas of the three squares. Observe carefully. What can you see? 64 plus 36 is 100. So what can you say? 64 is 8 squared. 8 squared plus 6 squared is equal to 10 squared. So that's the relationship between these areas. Question number 2. The value of root 500 cannot be found by using prime factors. Explain the reason for it. We'll check by dividing by prime numbers. Divide by 2, you get 250. Divide by 2, 125. Then divide by 5, 25. Divide by 5, this is 5. Again divide by 5, you get 1. So when you are trying to pair up the factors, here you can't pair up this 5. So that's why we can't find the square root of 500 using prime factors. So we can write square root of 500 is equal to 2 squared, 5 squared and 5. So here you can't pair up 5. Therefore, cannot use prime factors. Question number 3, show that 8 squared minus 5 squared is this and show the same relationship for another pair of perfect squares. We'll take left hand side. 8 squared minus 5 squared. Simplify, 8 squared is 64, 5 squared is 25. So you get 9, 9 plus 5, 14, 1 remaining, so 39. Now we'll check right hand side. 8 plus 5 and 8 minus 5. So you get 13 times 2. 13 times 3. 3 times 3, 9. 3 times 1, 39. So here left hand side is equal to right hand side. So this statement is true. Now we'll take another example. 9 squared minus 5 squared. So this should be 9 plus 5 and 9 minus 5. We'll check that. 9 squared is 81. 20, here 5 squared is 25. So what's the subtraction? You get 6 and 3, so 56. What about the right hand side? 9 plus 5, 14. 9 minus 5, 4. 14 times 4, 56. So this is equal to this. This is also true. So we covered all theory related to square roots. So we obtain a perfect square when we multiply a positive integer by itself. If a number is a square of a positive integer, then the square root of that number is that positive integer of which is the square. The symbol is this, and the square root of a perfect square can be found by observing the last digit of that number. When you get 2, 3, 7, 8, it's not a perfect square number. The square root of a perfect square can also be found using prime factors. So practice all exercises and examples and thorough with finding square root of a number.